This is, I think, at least it was for me, a quite interesting project because of the way we did it, but also because we were using our SCS, which is not a very common product. First, for those who don't know me, I know that there's some gentlemen here who do know me, but some of you don't. My name is Ruben Fernandez. I'm the automation team leader here at TVA Leicester. And to give a little bit more of background, I've been working as a research and development engineer for the railway industry, moving then to develop control systems for food production lines, moving after to maintenance area in an engine factory, and now here I am at TVA for the last 6 years. So I have quite a broad spectrum of the whole industry, I will say. And now, after introducing myself, let's introduce Linn. Might not be the most known company. Founded in 1973, they've been developing high-fidelity audio systems for the luxury market for the last 50 years. Their quality is so high, and their innovation is also that high, that the systems were installed in the cruise Queen Elizabeth, and also as part of Aston Martin cars. They were born in Glasgow, and they are still there, designing, improving, and hand-making their equipment there. Hand building is not against technology. In 1986, they created this factory with the peak technology at the time. And when I say with the peak technology, is that they actually installed a high bay with 3 automatic cranes, 6 conveyor sections, and 3 AGVs. AGVs in 1986 to feed their workbenches. All these workbenches, people are working, hand building, fed by this automated system. They have made a pretty nice video. It's only 2 minutes, so let me show it to you.
From the very first Sondek LP12 turntable, Linn has been bringing audio excellence to homes for over half a century. Innovation, precision engineering, and unwavering passion for music have led to our groundbreaking products being revered the world over. And for us at Linn, it all starts here.
When customers come for a factory tour, they think that perhaps they're going to be coming to a featureless industrial estate somewhere. Here they come to this very beautiful factory.
The company began in Castlemilk, on the edge of Linn Park. However, Ivor soon realised that in order to both improve and expand, he would need to design a purpose-built factory. One team has been on the right track since the moment the factory opened. Meet Huey, Dewey, and Louis.
When this factory was put together back in the mid-80s, Linn was probably one of the first companies in the UK to have automated guided vehicles.
This is our automated warehouse where we store all of our raw components, all of our parts that we finished in the factory go inside here. And then when it's time for assembly, our AGVs come round, pick up the parts and take them out to our assembly area. Ivor actually designed the factory with this in mind.
So those AGVs have served us really well. We're now going to retire them this year, and hopefully if we get 40, 50 years out of the next set of AGVs, we'll be doing really well.
Have you told these guys that they're getting made redundant?
That might be why they're trying to knock us down just now. They're not happy about it. Yeah.
Those were the AGVs that I actually saw when I was there. So they were running after 50 years. Right, so what were the challenges that we faced? Me personally, the first challenge that I faced was Scottish accent, I gotta say. But I gotta be honest, theirs were not the words that I've ever heard. So, not bad. Jokes apart, the most important one was the aging technology. As you can imagine, technology from 1986 is not exactly up to date. But also, the incoming of a new generation of workers. Aging technology was a challenge for several reasons. First, the AGVs, they were installed in 1986, no spare parts, purpose-built. Nobody knew how it worked. They didn't have backups of the software. In fact, during the creation of the project, the development of the project, the AGV system failed. It simply died. So they were actually happy that the project was developing at that time, because it only impacted their production for a couple of months. As you can see from at the bottom images, the control systems were also old. Even the SLC, which was an addition that they did in the early 2000s, is also obsolete. And the top left image, that's the user interface, if you can call it that way, that they had. That was all that they had. The functionality of the WCS was pretty much skeleton. It's just generating the orders, and that was it. So technology was really, really needing a refurbishment. The people working in the factory have been working there since the factory was built. They grew up with the technology, they got used to that. They didn't have a problem with the programming with a blue screen, if you know what I mean. But the newer generation is a generation of the smartphones, the generation of internet. They were not particularly keen on doing things with their own hands, I'm going to say. They needed to bring the technology to the 21st century. So how did we approach this? First, we decided to use an SCS rather than a WCS, store control system. What is an SCS? It's just a WCS based on a PLC. Because it's based on a PLC, it cannot do all the functionalities that our WCS can do. It cannot hold a database, it cannot store massive amounts of data, it cannot keep full track of absolutely every item on the inventory, but it can coordinate machinery to move a pallet from A to B. It can check the status of that machine. It can verify if a pallet can be moved or not. It can do certain low-level elements, which was precisely what Linn needed. We are expert in our field, but we are not expert in everything. So we make a multidisciplinary development. We developed the SCS, and we also upgraded the conveyors, making also the code modification in the cranes, because all those were PLCs. We can't upgrade an AGV, at least for now. So a Swedish company called AGVE took that job. And Linn themselves made the changes on their manufacturing system so it can talk to the SCS. Quality assurance was done all along the project directly by Linn. They know what has to be done, they know how the system has to behave, they know what's right and what's not. They also did all the electrical installation of our electronics. And since we were developing the core of the system, we took the overall lead of the upgrade program. Why did it work so well? For me, the most important by far is the first one. We worked as one team. From the very moment where the project was signed off, there was no TBA or Linn. We were a group of people with a goal that has to bring a system to life. We helped them, they helped us, sometimes even when someone might say that we shouldn't have, but we did anyway, because we were one team. We did a joint functional design. At the beginning of the project, we spent countless hours defining how the system should work. Dave knows what I'm talking about because we did the same thing with him. Countless hours. Putting that black and white on a piece of paper so everybody knew exactly how the system was going to work. That helped avoid that scope creep. going into a live system and getting someone saying, the system should do this. Well, nobody told me. That didn't happen. We used a digital twin. A digital twin is an electronic copy of the live system, live environment. When we developed the code, we also created a simulator. We created a simulator for the conveyors. We created a simulator for the cranes. HGVE supplied an emulator for the AGVs, and Linn also produced an emulator for the orders coming from the MES. We connected all this directly into the SCS, so the SCS really thought that it was running the factory when in reality it wasn't. All the functionality was tested using this. All the problems that might have arisen were mostly detected during that period. I mentioned before that they actually did the electrical installation of the system. That was a great advantage because they knew when they could install it. They knew, we have a couple of hours window, let's start connecting things. No impact on production, and because they actually did the installation themselves, on the very first day of go live, they already knew the system inside out. We use an MVP, which in this particular case is not most valuable player, but minimum viable product. As soon as we have one functional module developed, in this case was the jobs management, we deployed it. As soon as we have a HMI that could be used, even if it wasn't pretty, we deployed it. They started using the system. They started testing the system from the very beginning in parallel with development, providing feedback. That helped us, A, correct any errors on the go, and B, they got trained. Using this, again, on day one of go live, they knew how to use the system. They knew every single aspect of the system because they have been using it for months. And last but not least, remote commissioning. This is in Glasgow. We are based in Leicester. That involves flights, hotels, and so on and so on. Lots of preparation. But we did it from our home. That was very, very helpful because it gave us a lot of flexibility on adapting to changes. And it proved invaluable because literally 2 days before the go live date, production came and asked, can we actually do it next week? Because they had like a last minute order that they have to process, and it will be too risky to do it with the new system going live. No problem. Well, we are at home. We'll just simply do it next week. If we had the hotels book, that will be different. So what were the objectives that we were trying to achieve? Obviously, use of modern automation devices. That was the first one. They also use serial communications that, if some of you, as I know, have worked with it, I can see from your smiles, as you know what that entails. We also had to add new functionality, especially a new indexation method. So the racking were, let's say, better organized, and a new system interface, especially to provide better visibility on the fault finding. And we had to do this smoothly, without impacting production. Fortunately, we achieved all of this. The first one by using modern Allen Bradley Rockwell control logics and compact logics PLCs. That should be easier to upgrade now. And all the communications are now TCP/IP. Welcome to the 21st century. With the new indexation method, the racking organization improved. The pallets that are used more often slowly started to get to the front of the racking, and those that they only use for things like this, marketing events, to the back. They also have a better visibility of the stock. If an AGV breaks down halfway, there's going to be a big red light blinking indicating it. And they did meet their production goals from day one. They didn't lose a single day of production. There was, I think, a couple of hours delay on the first day, but they were counting for something way worse, so we are fine. As a matter of fact, we did the SCS go live one day, and the AGVs were planned a couple of weeks later. They did some tests on the integration, and we were ready to jump in if there was any issue, but no call came. So when I actually asked them, when are you planning to actually introduce the AGVs live? They say, oh, they've been running live for the last 2 days. Fantastic, thank you. So in phrase of Fraser Crown, the head of facilities, he was quite happy with not just the results, but also with the way that the whole thing went through. Process, documentation, the way we developed it, and also the support that we are now providing to the system, because that was another thing that for him particularly was dangerous. Don't leave the newer generation without someone to call if something goes wrong.